So say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo, say Geronimo.
In families of graphs, we're talking about graphs that have similar characteristics. So for example, all quadratic equations have the same kind of graph. They're all parabolas. All linear equations have lines for graphs. Those are families of graphs. Those graphs can all be broken down to the simplest form. The simplest form of every graph would be a parent function. There's several kinds of parent functions we're going to talk about today. The first one is a constant function, which is y equals a number. The domain of that would be all real numbers, and the range would be whatever number it is. For example, y equals 8, domain is all real numbers, the range is 8. Then we have identity function. And in an identity function, we have y equals x. So that would be going through the points 1, 1, 2, 2, 3, 3, 4, 4. The domain and range of that function is all real numbers. The identity function also includes our linear graphs. Absolute value, y equals the absolute value of x, that's the parent function for all absolute value equations. That particular parent function has a domain of all real numbers and a range of all real numbers greater than or equal to 0. Then we have the quadratic function, y equals x squared. The domain again is all real numbers, and then the range is the same as the absolute value. It's greater than or equal to 0. Now those parent functions can all be changed into other functions in the same family, either by translation, reflection, or dilation. Translation is a slide. We have two values that can affect how they slide. One affects how it goes up and down, and that's k, and the other one is h. That affects how it goes left and right. Now the k value, that's something that's added or subtracted to the actual function. If it's a positive k value, it affects how it goes up. A negative k value affects how it goes down. An h value can be found inside whatever grouping symbols we have, inside the parentheses or inside the absolute value with the x. That h value affects whether it goes left or right. A negative value would make it go left. A positive value would make it go right. It can also be reflected. When the entire graph is multiplied by a -1, that's a reflection across the x-axis. Things that used to open up now open down. Now reflections across the y-axis can be more difficult to detect in absolute value functions and in quadratics because those are symmetric on both sides. When we actually take the negative and put it in with the x and make that negative, that's what affects whether it flips over the y-axis or not. So typically, that negative would be found inside the parentheses with the x. Dilation shrinks or enlarges a figure, and it does it proportionally. So when we have a coefficient that's greater than 1, then that's going to be a stretch vertically, meaning it's going to climb up the y-axis faster than what the parent function did. If we have a coefficient that's between 0 and 1, that's a compression vertically. That's going to climb up the y-axis slower than what the parent function did. The first graph, A. Which family of graphs would you say A belongs to? It's part of the identity. Which family of graphs do you think B belongs to? Absolute value. Which family of graphs do you think C belongs to? Quadratic. Now there's two forms of the basic equation that helps us find h, k, and the a value, which is the dilation factor. The first equation, we have y minus k equals a times parentheses x minus h. Or you may see the same equation just rearranged a little bit to look like this. Y equals a times x minus h plus k. We saw this equation yesterday. These can be kind of changed into any one of the parent functions by making just a couple of slight modifications. First modification, if I just put a square up at the top, that makes this a quadratic. By making these into absolute value, I now have one of the absolute value equations. Notice h and k don't change no matter what parent function I'm looking at. Right now, it's an example of a linear one. This looks awfully similar to what we looked at in point slope form. Now, the differences between these two are very slight. The differences are h and k in this equation, you have to change them to opposite signs when they come out of the equation. Over here, h changes to an opposite sign, but k gets to remain the same sign. A is where we get our dilation. So this equation, I can rewrite this equation so that it looks a little bit closer to where I can see h and k. It already looks closer to the second one. If I just make one slight modification, this does not change the problem. Adding 0 doesn't change it. H is 0, k is -4 because it's on this side. We said it looked like the second one, so it remains the same sign. Remember, h tells me how it moves left or right, and k tells me how it moves up or down. Does it move at all left or right? No. Does it move up or down? Yes. It moved 4 units down. So our vertex is at 0, -4. You can use your calculator to find all of the other points. Simply go to y equals, clear out anything that's there, type in your equation. Where would I go if I want to see a table of values to graph it? I would hit second graph to see the table. Now your table may have giant numbers in there because we were messing with the table. Where do I go if I want to change and get numbers that are more reasonable for my graph? Second window and change it to something more reasonable like 0. So what are some other points on this graph? We're at 1, -3, 2, 0, and one more. 3, 5. Now remember, parabolas are symmetric. So I can reflect each of these points over the vertex so that I have the other side of my parabola. Make sure that all your parabolas have a round bottom because they are a U shape, not a V. H is -1. Changes signs regardless of which one it's in. What is K? 0. H tells me left, right. K tells me up, down. Tell me how it's moved. It moved 1 unit to the left. So our vertex is at -1, 0. What would be the slope? Remember, absolute values, we can tell a slope. 1. So from the vertex, go up 1 over 1, up 1 over 1, all the way across. You can reflect that across the vertex. Describe the reflection in each function, then graph the function. For part A, the entire parent function is being multiplied by a negative. That means it's a reflection across the x-axis. What is my h and k value? 0 and 0. So then what is my slope? Slope is -1, so down 1, right one. How do I get the other side? Flip it. Down one, left one. Next one. The entire parent graph is not being multiplied by a negative, just that x inside the grouping symbols. Therefore, it's reflected across the y-axis. To get a graph for this, you can type it into your calculator and find the table. Make sure you put parentheses where they're supposed to be. What's h and k? Both of them are 0. What are some other points on the graphs? 1, 1, 2, 4. And both of those points can be reflected across on the other side. Now we need to describe the dilation. 3/5, that's my A value. Is that between 0 and 1, or is it greater than 1? Between 0 and 1. So is it stretched or compressed? It's compressed vertically. When I graph this, it's just a line. So what's my y-intercept? 0. My slope is 3/5. Up 3 over 1, 2, 3, 4, 5. And then draw your line. Next A value is 3. Is that 3 greater than 1 or between 0 and 1? Greater than 1. So is it stretched or compressed? It is stretched vertically. Again, if we want to graph this, easiest way is make a table. So go to y equals, clear out what you got, type your equation in, go to your table. What is h and k? 0. What are some other points on there? 1, 3, and that means negative 1, 3 is also in there. The next problem. The manager of a coffee shop is randomly checking coffee drinks prepared by employees to ensure the correct amount of coffee is in each cup. Each 12-ounce drink should contain half coffee and half steamed milk. The amount of coffee by which each drink varies can be represented by f of x is equal to 1/2, and then the absolute value of x minus 12. Describe the transformations in the function. So we need to first identify h and k. H in this problem comes from inside these absolute value signs, and it's the opposite sign. So h is equal to 12. K is just 0. So this h value tells me that it moved 12 units to the right. K is 0, so it did not move up or down. It's also dilated. Since 1/2 is between 0 and 1, we can say that this has been compressed vertically. So to graph this, I'm going to count by 6s. So my vertex is at 12, 0. Then the slope is going to be 1/2. Since my scale is the same all the way around, I don't need to go up 1 and over 2 to have such a small graph. I can actually go up 1 bar and right 2. If you have any other questions, feel free to come see me during early session.